Hi, welcome into my channel. This channel is against the Big Bang. Again, I am saying like 90% of the current day science is wrong. So, but in this video, I want to speak about quantum computing. So, if you know, I cut from some video like this.
It's been a while since we talked about quantum computing. It used to be that there were basically only two approaches to quantum computing: trapped ions and superconducting circuits. And those are still leading the pack, but other approaches are catching up, and there's good reason to think some will take over in the next couple of years.
So you saw I cut from some video and I comment a video. So Sabine Hoffenfelder about quantum computing. So she says that there are two ways of they tried quantum computing. So I cut for exemplification, and I comment. Okay, so you look.
Superconducting circuits is the main approach that's been pursued by Google and IBM and Rigetti, among others. The downsides of this technology are that the qubits need to be cooled to a few millikelvin and that they have a coherence time that's a few tenths of microseconds on a good day. The coherence time measures how long the quantum effects last, and a few microseconds is hardly long. On the other hand, these qubits can also be operated and read out very quickly, so the short coherence time isn't necessarily a disadvantage. Superconducting circuits are also the technology that Google used for the first demonstration of quantum supremacy. That's when a quantum computer performs the task faster than a conventional computer, though it's since been renamed to quantum advantage because reasons.
So you watch that. I'm saying like a tea science, coffee science. I have always see something to drink. This is like a justification. This is a mint tea, mint from my garden. You see. So what I'm telling you, I'm telling you from the beginning. The computer does not compute anything. Anything does not compute. It's showing to you pictures, and the programs are ways to arrange some functions on some pieces. So if you want to understand quantum bits and things like this, you must understand what is the bit. And so that's why I cut again from a guy's YouTube channel. You'll see it. He is explaining to you what is a bit. Okay, so look.
Let's continue our discussion of digital storage terminology. Digital storage uses the binary system, where everything is saved as ones and zeros. The word that's used to describe these ones and zeros is a bit. It's short for binary digit, and it's the smallest unit of data in a computer. These bits, these ones and zeros, are used to store all kinds of information, from text documents to the digital photos that you take to the sounds that come out of your speakers. To store this information, we use a whole bunch of bits put together. The number of bits we have determines how much data we can store.
So after you watch that, he is telling you that it is storage. Storage, a bit is not a unit of processing. It is a unit of volume somehow, a space, an area. So if you do not believe, this is a 4.7 gigabyte CD. What does his process? Does not process anything. It is a storage, and they are tricking themselves like somehow if you have quantum bits, these bits will process very fast. So that's why you must understand first of all that I'm saying that even that the quantum mechanics is false physics on hydrogen states of nothing. So if the quantum mechanics itself is stupid science, how you can have some computer that computes with quantum mechanics, but you do not understand but that the bits are storage units. You can store images. So I cut another part from this guy. Look.
You can think of 1 byte as the amount of space required to store a single letter or symbol in a text document. So if you wrote a paragraph with 500 characters, that would require about 500 bytes of storage space.
So it's telling you about some floppy disks, if you know, 1.4 megabits. This is a stick like 7 megabits stick, you know this, okay? So does this process? No, but has a capacity of storage in bits. This how they were defining it, not having a good ways of in a mathematical process with 0 and 1s by naming even something of the property of light, okay? So it is a storage profit, you might remember this. So this CD is processing something, it is calculating. You can have movies here, 4 movies, or I don't know, music, okay? So you must understand that the music itself can be like an image, stored with light. You imprint here light. I break up a CD to show to you. So they made a substance, like you see chemical substance, they imprint it here, and that substance is capable to have like 7 notes, tones of colors, and you can imprint images. So this is not calculating anything in bits in the same way the computer does not calculate. It is a trick. How the trick comes? But let me put another part from Sabine Hohenfelder, okay? So I cut from a video to show to you that they do not know what I am talking about. So listen.
Quantum advantage, however, just means that the calculation was fast. It doesn't mean that it actually produced an interesting result. The calculation in question basically produced a certain random distribution.
You see, it is a spell of the language. When you read a book, when I read philosophy, the spell, it seems to you that it is correct somehow. You read another book, that's why you do not have capacity to decide. But I'm telling you that the byte, it is, and they have a quantum byte, a mathematical way of arranging numbers and a mathematical trick to say somehow that, but the computer does not compute anything. If you do not understand, I let you watch a minute. I fill my monitor a game. That's a processing. Let's say processing images. So look for a minute. This is a game. Heroes. These are examples of programming. The computer does not compute, has some programmed pictures, displaying pictures. Look, it's playing an example. It is nice. Heroes is the game, an old game, but if you understand, he is showing to you pictures, only pictures, in a temporal manner. It is programmed to show you pictures. So the computer does not compute anything. It does not calculate. You see, like Heroes, an old game. Okay, though it's showing you pictures. You understand? It's showing you pictures. You see, from a game, old game, Heroes. It seems to you it plays automatically. It expose pictures only, and it is that's a way of arrangement. That's so mathematics to go from a picture in another picture, because always on your screen you see a picture. So even the link, and when you open a link, it goes in another pictures. So it jumps from here to here, a link. But it is put on a, so everything is a storage mechanism. So what do you will compute? Nothing.
1 kilobyte is enough space to hold about 1/3 of a page of text, Back in the late 1970s and early 1980s, the 5¼ inch floppy disk was a popular storage medium. It could hold 360 kilobytes of information.
So, but now you must understand that there's a limit of transmission or of a download. So you have 4 gigabytes here, 120 minutes, they say. It will be better to read it at once, like 1 second, and you read 1 gigabyte. You see the pictures are here, like you have an album, and you look fast, and you see. So you have a cable, you have a cable, like your internet cable. You now are interested how fast you can transmit, but pictures, you understand, you have 2 parts, music and pictures. So you must now think how to transmit or read. So a quantum computing bullshit that does not compute, it reads, and you are interested how fast you can read from this. To download this 7 gigabytes in 1 second. So how do you do this? The pictures are in here, but they are pictures, and the music itself is stored in the picture manner, and it is made a conversion between the picture of the music stored in light here, and it's converted in sound. So it goes to earth. So you have pictures of sound here. So everything is a storage picture. Maybe you are smart, you see, but these guys are tricking you.
A similar feat was achieved by a Chinese group in 2021. They measured coincident arrivals of 100 photons, and again that produced a random distribution, which is difficult to calculate by any other means, though this random distribution could one day have some applications. Here's a photo of their setup. Then, earlier this year, IBM made up for being beaten on quantum advantage by claiming the first demonstration of quantum utility, again with superconducting circuits. They used a quantum processor with 127 qubits called the Eagle processor to calculate.
But I want to tell you that 90% of the science is wrong. Einstein, quantum mechanics, everything that they are tricking you. I wanted to speak about the Big Bang. If you know the Big Bang is false, the stars are close and can go to the stars, okay? And they are lying. But in this process, I want to demolish everything that they are tricking you with, okay? So what is quantum computing? This computes, does not. So now you are interested how fast you can transmit. There is a limit how many pictures you can put on this cable to transmit it on the second. There is a limit inherent in a material, and there is a limit of reading, how fast you can read something, how fast you can read this, how fast you can read this. So you must pass energy through it, and it copies all the pictures that they are, but they must be transmitted somehow. And you understand that a bit it is a unit of space. The guy explained to you, if you understood, 0, 1, you need this quantity of space volume basically to store a picture.
1 megabyte is enough space to hold about 1 book, 1 photo, or 1 minute of music. Keep in mind, those are approximations and could vary widely based on the quality and type of encoding. The 3½ inch floppy disk, introduced in the 1980s, could hold 1.4 megabytes of data.
You identify us, you see I cut the CD, and there is a substance made from some few chemical compounds that's susceptible to all spectra of light, Rockwave gamma tone of the rainbow. So that's how you put all the frequency of light in this chemical compound, and you simply spray it on this plastic stuff. But it does not compute, you understand? In the same way, this is storage. Store the computer, the telephone, the phone, it stores pictures, pure pictures, and there is something in mathematics of processing, but there are mathematical function to take from here to go there, like a program. You program a sensor to go off and on in 10 minutes, or a TV goes off in 10 minutes. So this is programming. This is only thing that the computer computes somehow. It manifests program like in a game. You give them pictures and ways to go from a picture to a picture. So in a game you have many possibilities of geometry. You understand? So in this manner you understand the computer does not compute anything. It is a way of showing to you pictures. Even in mechanical computers or computers with like a philosopher made that. Okay, the first one for his father was an economy. Pascal, Blaise Pascal. You put numbers on wheels and you turn them, and it is programmed like in mechanical programming to show to you. You put 2 times 2, they will turn, show you 4. So it is a way of showing you picture, but in this manner, in a mechanical manner, in a mechanical process. So now you are interested how fast you can transmit pictures through this cable. This cable does not process anything, it transmits it. So it is a way of transmitting and copying and reading it. So now if you flow energy through all the pictures, that you not derange them or delete them, okay? You can copy all at once, but it is a limit of transmission. So now you can break a pictures like mathematical, like they did this, okay, in lines, in columns, and you can transmit at once. Like this is how can you improve. But quantum processing, what it means? It will be a way of mathematical understanding to maintain the coherence of the picture in here. You can somehow make a code that to flow energy through it, to copy but you know how the pictures will arrange or rearrange, because you must rearrange them in a coherent picture to display them. So they will make a quantum computer if the quantum mechanics is false physics.
What's called the trotterized time evolution of a 2D transverse field Ising model. What the heck is this? The Ising model is a model of coupled quantum spins. Transverse field means it's a complicated version of that model. That it's a trotterized time evolution means they use a specific method to calculate how these coupled quantum spins change in time. And 2D means transdimensional doodles. Just checking if you're listening. Now, this is a pretty amazing calculation if you're interested in the Ising model, but I think it's fair to say that this isn't exactly everyone's notion of utility.
So they can they do a quantum computer? So they are tricking you, but you do not understand. These were inventions. Some guy invented a solution, like in a audio tape, videotape, and this solution, chemical compounds are responding. You see, they put it into, you see, and they painted it, simply painted it, and this solution exactly like a picture. So there's small pictures here. So there is a limit of zoom. You can put a small picture here to zoom it, to multiply them with the transmission, with the transistors, like, okay. So there is a limit of space per volume per picture. Here are imprint pictures. You understand? So you cannot make only the smallest zoom that you can make to maintain a coherent picture. So in this manner, there's a limit of putting on every substance, chemical substance of picture, because these registers of picture in a chemical manner, put in a geometrical pattern arrange, like, and they were, when they spin, they read it. They read it, and you are interested to read it fast, to transmit fast this.
The current record for the number of physical qubits is 433 and is the IBM Osprey chip that they're planning to make available in the cloud soon. IBM also has a roadmap according to which they want to reach more than 1,000 qubits later this year. They say this will be a modular approach which can then be scaled up to 1 million within 10 years. Google has its own roadmap with certain milestones but hasn't put particular dates on it.
Okay, so this is the problem. But what is the quantum computing? Because the normal computer does not compute anything, does not calculate how this Sabine Hoffenfelder says. What calculates? Like you believe that the computer can discover mathematical dilemmas that the man did not resolve. The computer does not processes anything, but it processes. But it processes. It means to arrange in a function of time some pictures, some all the temporal processes that you are giving to this. So many times they are pictures, if you understood. So if you understand. The more complicated programs that they are Windows or these are some processes. So they obligate to display the pictures. They are like a frame for the pictures. You see, you have a picture, you have a frame. Is a frame like is a frame to put pictures in it. It is capable to, you understand. So nothing processes quantum quantic. If only you have a mathematical way of, you understand. So nothing is like physical, like quantum mechanics, and now you have some material that acts like quantum, and now they are bullshitting you to understand that somehow they process this. The Chinese, she says, but they did it in 5 minutes or something. You look.
Google published its demonstration of quantum advantage in 2019. They used a 53-qubit quantum computer and claimed that they succeeded in 3.5 minutes with a calculation that would have taken 10,000 years on a conventional computer. The 10,000 years claim was swiftly questioned by IBM, and indeed it was later done by a Chinese group on a conventional computer in only 5 minutes.
Because was the problem is the word calculating or not. But you must understand how fast you can go through data. How fast. If you like in a checkboard, you have some rules to process them, to display them. To make like this, and make fast, okay? And you give a set of rules. So what it is processing? In a way, you must understand it displays pictures in a temporal manner. So you have a function per time, you give the time, and it displays. So the quantum mechanics and quantum computing are false problems, because the materials do not comport quantum mechanics. Only if you have a way of mathematics that it will obligate to not be like in a classical manner already defined somehow, like with bit 0, 1 bits, a geometrical way of arrangement, okay? Maybe that's why you have 2 wires, maybe some other time. And you obligate, when you copy to the matter, to comport with that new mathematics. So you flow energy through all of this, and you bring it at once in your computer. You download it at once, you put it, and it makes an instant copy, even though here is like 2 hours or 3 hours, 4 hours of music or pictures. So maybe you understood I am against the Big Bang only, but this is the tricks that he employed. You do not know Einstein, gravity, physics, quantum mechanics. These are all this like dust throw in your eyes. Do not understand. And if I thought with the Big Bang, that the Big Bang is false and we can go to the stars, I'm telling you, the stars are close. Our galaxy is a sphere. So that's why I treat these other problems, but you understand that it is coherent, okay? So goodbye, God bless. This is against the quantum mechanics computing like package. My mint tea from my garden, you see. So it is a little bit for you to understand that quantum mechanics is wrong, and they are like quanta, brain, quantums, like here, where quantum. So this is to end with a joke. So it is a storage unit, 0, 1, a geometrical storage unit. Believe it or not, this is the way how they did it. Why not? And the guy tells you, if you paid attention, you with a bit you can store a letter A, B, because you understand it is a way of displaying it. Okay, so goodbye, God bless against quantum mechanics. We can go to the stars. The stars are closed. This is what I wanted to tell you, but I don't have anything but to maybe to bring to say to you, because I already told you. So I treat another problems. Maybe some people will understand. Goodbye. God bless.